Hello, Algebra 1. We're going to take a look at our 9.7 samples in preparation for our quiz 9.7. So in this lesson, recall that we are solving systems of equations where one of the equations in the system is quadratic and would graph into a parabola, and the other equation is linear and would graph into a line. So we're looking for the 0, 1, or 2 points of intersection between the parabola and the line. So we're going to use our algebraic techniques to find those points of intersection if they exist at all. So for our first problem here, we have two equations that are both equal to y. That means that substitution is going to be an ideal way to solve this system. So we can take either of the equations, doesn't matter which one, and substitute the value of y into the other equation. So I've chosen to substitute negative 2x squared plus x plus 1, which is the same thing as y, in for this y. So I've rewritten the second equation as negative 2x squared plus x plus 1 equals 5x plus 1. Now I don't have any variables that are y, I only have x variables, so I can solve this equation for x. I notice it's quadratic, so I'm thinking factoring might be a good method to solve this equation. So I want to get equal to 0 to see if I can in fact factor this equation in order to solve it. So I'm going to subtract 5x and 1 on both sides. That'll give me negative 2x squared minus 4x is equal to 0. And I'm noticing that, yes, I can factor this quadratic equation using greatest common factoring. I'm going to factor out a negative 2x. What remains behind will be x plus 2, because negative 2x times x is negative 2x squared. Negative 2x times positive 2 is negative 4x. I have two factors multiply together equal to 0, so I'm going to use the zero product property that says take each factor separately, set it equal to 0, and solve. And you'll find any x values that solve this equation, and there are two of them. So when I solve negative 2x equal to 0, I divide both sides by negative 2, and I will find out x is 0. Remember, 0 on top, okay, 0 on bottom, no way. So x is 0 is one of my x coordinates that will be a point of intersection for the parabola and for the line. The other equation, x plus 2 equals 0, I'm going to solve by subtracting 2 on both sides, and that will give me x is negative 2. Now I need to find the corresponding y values for x is 0 and x is negative 2 to find the 2 points of intersection. So I'm going to go back up to my original presentation of my system. I'm going to pick the easier looking equation to plug x in to figure out my y, which clearly will be the second equation. You can pick either one, but pick the one that looks easiest. So y equals 5x plus 1, I'm going to plug in 0. And then for the same equation, I'll plug in negative 2 for x. I'm going to work both of those out and find out that when x is 0, y is 1. And here when x is negative 2, y will be negative 9. So the 2 points of intersection for this parabola and this line will be at 0, 1, and negative 2, negative 9. So this line and parabola will intersect at 2 distinct points. Sample 2. Same idea on this one. There's more practice of solving a system that includes a quadratic equation and a linear equation. So our first step will be to substitute and in this case I'm going to use 4x squared plus 5x minus 7. I'm going to substitute it in for this y value because it is the same thing as y. So 4x squared plus 5x minus 7 is equal to negative 3x plus 5. Then I'm going to add 3x and subtract 5 on both sides. And I will, the result I will have is 4x squared plus 8x minus 12 equals 0. So this again is a quadratic equation. I am going to be using factoring to solve this quadratic equation. The first thing I'm going to notice is I can factor out the greatest common factor of 4. So I'm going to rewrite my equation as 4 times x squared plus 2x minus 3 equals 0, because 4 times x squared is 4x squared, 4 times 2x is 8x, 4 times negative 3 is negative 12. And then I'm going to divide both sides by 4, and I have a much simpler equation to factor. X squared plus 2x minus 3 equals 0. I'm going to factor this trinomial into x plus 3 times x minus 1, because x times x is x squared. My outside, negative 1x, plus my inside 3x is 2x. 3x minus 1x is 2x. And 3 times negative 1 is negative 3. I'm going to use the zero product property, set each factor equal to 0, and solve both of those equations, and arrive at x is negative 3 or 1. So again, this parabola and this line will intersect each other at two distinct points. I know the x-coordinates of where the parabola and the line intersect. I now need to find the corresponding y values for these x-coordinates. I'm going to go up and pick the easiest looking original equation, which will be this linear equation. I'm going to plug in what I got for x. I got two different values for x. I'm going to plug in both of those values for x to find the corresponding y. That's what I'm doing here. So here I'm just rewriting the linear equation from my original presentation of the system. So y equals negative 3x plus 5. I will substitute in negative 3 for x, and I will find out the y value that corresponds to when x is negative 3. The y value will be 14. And here I'm going to substitute in 1 for x, and then I'm going to work out my corresponding y value, and that will give me 2. So these are the 2 points of intersection of the parabola and the line. The intersection of the parabola line will happen at negative 3, 14 and at 1, 2. And that concludes our samples for this lesson. It's now time to make sure this is in your notes and understood and move on to the quiz. See you next time.